graders, how are y'all doing today? We're coming to you from, well, the science lab, where we always come to you from. Where else would we be? We got some exciting news for you today. Did you know, I mean, this is just in, scientists have discovered that they can actually identify an unknown substance by calculating its density. Isn't that the coolest thing ever? They didn't really just discover it, we're just getting around to telling you about it. But scientists can do that. All they have to do is get the measurements of volume and mass, and then they do calculations either in their head or the calculator, and they figure out the density, and then they look it up and see what that substance is. And you know what? Scientists can do it because they're professionals, they're smart guys and everything. But you also can do it. You too can calculate density. We're going to show you how. Okay, but first, you kind of have to know what density is, right, to have some idea of what you're doing. So, y'all remember when you were in elementary school, right? Of course you do. That was not too long ago. But when you were little, did y'all ever do like the floating and sinking experiments, see what's going to float in the water and what's going to sink? Yeah, you did that? Okay, when you did that, you were exploring density. You just didn't know it. Your teachers didn't tell you. They kept it a big secret from you because you weren't really ready for that. But now you are. You're in middle school. You're ready for density. So here's what density is in a nutshell, or whatever substance. It's how much matter is packed into the space that something is taken up, right, or is taken up by that object. So, you know, we've been talking about mass measuring matter. We've been talking about volume measuring amount of space that something takes up. So how much stuff is crammed into the space? That's density. The more stuff that's crammed into space, the more dense something is. So it seems like it's heavier or lighter because of its density. So really quick reminder, you know, solids have their particles really tightly packed, right? Liquids have a little bit more space between their particles. They move around more. And gases have the particles spread out even more. That means that gases are the least dense. Liquids are a little bit more dense because their particles are close together. And then solids are the most dense out of those three states of matter, right? Because the particles are most tightly packed. But what if you got two different solids that are the same thing, right? Like I've got two different rocks. This is a big old heavy block of basalt. That's an igneous rock. This is another igneous rock that's granite. It's not quite as heavy. Now they're not exactly the same size, but they're pretty close. What you're going to learn when we do the earth layers, you're going to learn that basalt is more dense than granite. And so oceanic crust is more dense than granite because the type of rock is more dense. This has more matter packed into it than this type of rock. They're both pretty heavy. But this one is heavier because it has more matter packed in to the same space that this one would if it's the same size rock. Okay? Think about this. If you were to go bowling, this is about the same size as a bowling ball. It's a soccer ball. About the same size. I can't find my bowling ball, so I'll just grab my soccer ball because it's about the same size. So if I take this bowling ball and I roll it down the alley, I'm not going to do much with the pins because it's not heavy enough, because it's not dense enough, right? It doesn't have enough stuff, matter, packed into it. But if I use the bowling ball, of course, I'll knock down the pins. If I use a bowling ball, I'm not going to kick this, because it would hurt, right? Too much matter packed in there. So let's pretend. Well, actually, let's look at these first. We got a baseball, tennis ball. Which one of these would be more dense than the other? Yeah, the baseball, of course. Y'all know that because there's more stuff packed into the baseball. There's a bunch of air in this, right? There's still matter there, but not nearly as much. It's more spread out. So these are close to the same size. This one's got a lot more matter packed into it, so it's more dense. It feels heavier. Same thing with a ping pong and a ping pong ball and a golf ball. Less matter packed into about the same space. This is less dense. That's more dense. This one is heavier than that one. All right? That would be density. Okay? The way that we look at density is we look at how much space is taken up. So let's pretend this is a rock, and it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little blocks of space. This is a piece of wood. Same exact size, 10 little blocks of space. This would be heavier because every individual little space, that's volume, has more matter packed into it than every little space of matter here. Okay? Whether it's a big rock and piece of wood or a small rock and piece of wood. It doesn't matter what size the object is because every individual little piece has a certain amount of matter packed into it. Okay? So both of these pieces of wood are lighter and less dense than both of these rocks that are the same size. Make sense?
Yeah.
Great. Okay. Let's see. Same thing with a Kleenex box. This one has no Kleenex in it. This one is full of Kleenex. They're close to the same size. Which one of these would be more dense? Right, this one that's full because it's got more stuff packed into it. More matter packed into the space. Mass in the volume. What about if I'm going on a trip? Oh, a trip, and I've got this big heavy bag that I've got all this stuff packed into. It's so heavy because there's so much matter packed into it. I don't want to have to lug that heavy stuff around. I'm just going to take everything out of here. Okay? And that same bag, same size, still takes up the same amount of space. Oh, but so much lighter because now it doesn't have so much space, so much matter packed in this space. So this is less dense. That was more dense. Now it's not. Okay. Ms. Hodson is going to tell you how to calculate the density so that, yes, you too can calculate density on your own so you can identify an unknown substance. That will be coming to you soon. Stay tuned. Don't go away.